Hello. Today we are interested to prove this important result as a theorem, and which says that in an integral domain a prime element is always an irreducible element. So we start with the proof, and first we suppose that D be an integral domain and P a prime element. Prime element in D. Since P is prime, so P is non-zero, non-unit. Now we show that P is irreducible. Claim P is irreducible. Now to prove this, we let P as a product of two elements B and C for some B, C in the integral D. Now if we can prove that either B is a unit or C is a unit, in that case the conclusion will be that P is an irreducible element. So now we show that either B is a prime, B is a unit, or C is a unit in G. Here P divides B. We can write this as P can be written as P at 1, where 1 is the unity in D. We can write this one. So this can be written as P divides. Now we put BC in place of P on the right. So it is BC from there. Now P is prime. And we know from the definition of a prime element that if P divides the product BC, then either P divides B or P divides C. So since P is prime, either P divides B or P divides C. Now two cases arise, this one and this one. Now we consider the first case. So case 1, if P divides B, then we get B as the product of P with some X, where X is in D. So we found that B is the product of P and X, and here it is given P equal to BC. Now we use these two relations. Now we write P is equal to BC, and we put Px in place of B on the right. So we get Px C. Now by associativity we can write Px C, or P is equal to Px C, or we write P minus Px C equal to Px C minus Px C, adding minus Px C on both sides, or P this one will be 0. Now P can be written as P dot 1 minus Px C, this is 0. Or by distributive law we can write this one on the left, P 1 minus X C equal to 0. Now we have found so far that P product of P and 1 minus xc is 0. These two are elements in the integral domain D, and in the integral domain there is no zero divisors, and here P is non-zero, so we must have 1 minus xc is 0. So since D is an integral domain, E is non-zero, so 1 minus xc equal to 0. So from this relation we write xc equal to 1. Now since it is integral domain, so it is commutative, so we write x equal to cx, so it is also this. Now from the definition of unit elements in D, C is a unit in D. So we started with the first case where we have supposed that if P divides B, then we obtain that C is a unit in. Similarly, in the case 2, if we start with if P divides C, then we can show that B will be a unit. If P divides C, then we can show that similarly that B is a unit in D. So we have found so far that whenever P is the product of BC, either B is a unit or C is a unit. So P is an irreducible element in D. So the theorem is established that every prime element is an irreducible element in an integral domain.